Today we want to continue our look at the law of cosines. We're going to look at the three versions of law of cosines and see what we're using it based on to find based on what we are given or what we have. So we know that we could use the law of cosines to find a side or an angle depending on what we have. There are two starting cases where we have all three sides. That's the side case, or side angle side, two sides and the angle of the included angle, the angle between two sides, the included angle. So the side case is a little bit easier. That's more flexible. We can use, if we have the three sides of a triangle, we can use the law of cosines to find any one of the angles. Notice that in all three of our angle versions for gamma, beta, and alpha, they all have side A, side B, and side C, A and B. Side A, side B, and side C, A and C. Side A, side B, side C, and then B and C. So in all three cases, we could use the law of cosines with three sides to find any angle. So this is where we have A, B, C, have A, B, C, have A, B, and C. So all we have to do is pick one. My recommended course of action is to find the biggest angle first. For no other reason than that takes away a decision that you have to make. It's not like in the law of cosines, I could mess with you. If there's going to be an angle, if there's going to be a triangle and everything's going to work out, it doesn't matter which one you find first. But my recommendation is go for the biggest angle first. We could use the three sides to find any of the angles. My tip is to find the biggest angle first. On the other side of using the law of cosines, in the side angle side case, we don't really have a choice of what we find first. If I give you two sides in the included angle, you don't have a choice about what you find first. For example, notice that in this first line, c squared is equal to a squared plus b squared minus 2ab cosine of gamma, we have a, b, and gamma. If you have a, b, and gamma, the only thing that you can, more importantly, if all you have is a, b, and gamma, the only thing that you can go looking for is C. If you have A, B, and gamma, the only thing you can go looking for is C. Two sides, A and B, the included angle, gamma, the one that isn't opposite the two given sides. Notice that in B squared is equal to A squared plus B squared minus 2AC cosine of beta. This is when we are given A and C and the angle beta. So here we have A, C, and beta. Our only choice is to find side B. If all we have is A, C, and beta, our only choice is to find B. So I guess that means we don't have a choice. And then finally, in the a squared version of the law of cosines, we have B, C, and alpha. Our only choice is to find A. In the side case, we can find whatever angle we want first. My recommendation, find the biggest angle first. The biggest angle will be opposite the biggest side. So in the problem that we had today, with side A at 23.4, side B at 13.5, and side C at 29.1. If I didn't direct you to find a particular angle, I would find angle gamma first, because that's the angle opposite the biggest side, so that will be the biggest angle. So that's just my advice. Find the biggest angle first. Any questions? Once we do one of these things, we have 4 of the 6 pieces of information. And so now we have lots of choices for how we proceed. So good news. Once we know 4 things about a triangle, we have lots of ways we can proceed. Bad news. Once we have 4 pieces of a triangle, we have lots of ways that we can proceed. We all like to think we want choices until we have to make choices. The nice thing is with the law of cosines is that you don't really have a choice to make. If I give you 2 sides in the included angle, it's easy to see which side you're going to go find first. The other thing to note that we want to point out when we're doing the law of cosines is that in our given information, we don't have a set of opposite information. In none of these cases do I have A and alpha, or B and beta, or C and gamma. So we use the law of cosines when we start off without an opposite pair. So note, law of cosines when we don't have an opposing pair. It's law of cosines for us when we don't have an opposing pair. That's A and alpha, B and beta, C and gamma. Nothing matches. Nothing matches. Law of cosines. How's everybody okay? What law do we use if we do have an opposing pair? I haven't even told you what it is, but you know, you're all thinking it. I've read your minds. You're thinking, is it law of sines? It's law of sines. Law of sines is what we use if we have an opposing pair. Any questions before we move on to law of sines? How's everybody okay? We look super stoked. Oh, I can't wait for the law of sines. I'm at this way zoomed out angle. No, it's fine. Maybe I'll just write bigger. The law of sines says the following. Law of sines says that the ratio of the sine of an angle, the side opposite that angle, is constant in any triangle. You don't want to copy this part down. I mean, maybe you do. I don't know. I should decide what you want. But it's not the functional part. The law of sine says that the ratio of the sine of an angle to the side opposite that angle is constant in any triangle. This is the version of the law of sines that we say when we don't get to write down like symbols. It's the difference between saying the Pythagorean theorem is a squared plus b squared equals c squared versus the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. the ratio of the sine of an angle to the side opposite that angle is constant in any triangle. So we'll say sine alpha over A is equal to sine beta over B is equal to sine gamma over C. Or we can do the reciprocal all the way through. I think which one you prefer is just going to depend on which triangle you like better. Like this one over here, this is if you like all, I like this kind of triangle. I want my triangle to have a nice base on which to sit. But over on this side, you're like, oh, no, 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 the pointy part should point down. And the wide stuff should be on top. I don't know. I haven't figured this out yet. I should have had a survey. Right. It's just like, I'll pick one of these triangles, and I just have these two triangles. One's kind of pointed down and one's pointed up. And you're like, well, is this some kind of psychology thing? I'm like, oh, just pick one. And then you try to figure out what weird psychology I'm trying to do. It's like if I had the final exam for trigonometry, it's like, oh, problem 1, 2 plus 3, end of test. You'd be like, oh no, I'm super suspicious about that. The law of sines is what we use when we have an opposing pair. So it's sines when we have an opposing pair. Notice that if I had, it has 3 parts, sine alpha over A equals sine beta over B, but we're only going to use 2 fractions at a time. So if I have sine alpha over A, sine beta over B, one of the things we're going to need is A and alpha or B and beta. So we use the law of sines when we have an opposing pair. It's sines for when we have an opposing pair. We have to be able to make one whole fraction. So I need an alpha and an A, or a beta and a B, or a gamma and a C. Notice that if I have A, B, and C, that's the denominators of all 3 of these fractions. That doesn't help me. Because if I have the A and the B, I'd have alpha and beta. That's no help. Or if I had A, B, and gamma, I'd have A down here, B down here, but gamma is over here in the third one. I can't solve an equation if there's like 3 sides to it. So the good news is you can't mess this up. If you want to use the law of cosines, you have to have an A, B, gamma. If you have A, B, and gamma, you know you can't do the law of sines because you don't have an opposing pair. Any questions? Here's an example of a setup where we would use the law of sines. The reason that we know that we're going to use the law of sines is that in our given set of 3, I've got A and alpha. That's what tells us we're going to use the law of sines. I have a given opposing pair of information. I have A and alpha. Before we even use the law of sines, what would we want to do first in this particular problem? What's the most reasonable thing to do first? Notice that in the setup of this problem, I have a side and two angles. In a triangle, if you have two angles, subtract to find the third angle. As soon as you have two angles, subtract to find the third angle. So because we have two angles, I'm just going to immediately do 180 minus the number I just covered up, 32.1 minus the number I just covered up now. As soon as you have two angles, subtract to find the third. That's just good practice. So to set up the law of sines, we know we're going to be using the law of sines first because law of cosines is not available to us. I only have one side. Law of cosines requires two or three sides. So this is definitely a law of sines problem. So we'll set up sine of 32.1 alpha over side A, 15.7 is equal to sine of beta, 24.7 over side B. Here's our ratio of the sine of an angle to the side opposite the angle being constant in this triangle. To solve for B, we multiply by B and then divide by this fraction. So we'll have 15.7 times the sine of 24.7 divided by the sine of 32.1. Now we've got, see, 4 or 5 parts of the triangle. The last thing to find is side C, and we'll use the law of sines again. I suppose at this point, if we really were dedicated to the law of cosines, we could go and use the law of cosines. That would be very strange. So we're going to use the law of sines again, and I'll just use the same alpha and A, the given stuff. Use as much given stuff as possible. Sine 32.1 over 15.7 is equal to the sine of 123.2 divided by C, the new thing I'm looking for. So C is equal to 15.7 times the sine of 123.2 divided by the sine of 32.1. So I'm going to do this calculation, but trade my 24.7 for a 123.2. Any questions? Is everybody okay? This case is called angle side. So I've got two angles and one side, and the side is opposite one of the angles. So this is angle side. This case is called angle side angle. I've got two angles on one side, and the side is in between those two angles. I've got two angles and the included side. What we notice that we don't have in this set of information is an opposite pair. I've got side A, but I don't have angle alpha. I've got angle beta, but I don't have side B. I've got angle gamma, but I don't have side C. So I don't have an opposing pair of information. But this is still law of sines. What would we do first? Yeah. Find the third angle. We're given two angles, subtract to find the third angle. And the third angle that we'll find here is alpha, which will give us an opposing pair. So alpha is 180 minus 67 minus 51. 62 degrees. We didn't start with an opposing pair, but we had two angles, and that's as good as having three angles, because that's just subtraction away from having all three angles. So we didn't start with an opposite pair, but we had two angles, and so we just have to subtract. And now we have alpha and A, and we can set up our ratios. Any questions? If you have two angles, you almost have three angles. You're only subtraction away from having three. So that first example is angle side. The second example is angle side angle. It's not a real example. I just made that up on the spot. Law of sines wants an opposing pair to make one whole fraction. If you have two angles, that's just as good as three angles, because all we have to do is subtract. Is everybody okay? When you have two angles, this is the good version of law of sines. If you have two angles, you might as well have three angles. It's almost like I'm giving you four pieces of information. And when you have four pieces of information, life is simpler. You can just jump into your law of sines. Any questions? Yes. I don't know. It depends. Every time I try to write these reciprocal, like write A over sine alpha, I start writing things in the wrong spot. I am clearly this triangle. This is my brain's triangle. I put the sine angle on top. That's a great question. What's easier for you to write? So some of you might prefer, try writing 9.8 over sine 62 equals C over sine 51. And then that means that you're just this kind of triangle. If you're like, oh, no, I like that better, then you're this red up triangle instead of a green down triangle. So we'll break into teams on Thursday and we'll, I don't know, battle it out somehow. How about paintball? No, that's crazy. We can't have paintball in the room. Be like a Tarantino movie. So there is something I left out. There is a case that we have left out here. I've had side, 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 angle, side. Those are the two cosines ones. We've had angle, angle, side, or angle, side, angle. Those are the two sines ones. The other one is two sides and an angle opposite one of those sides. Two sides and a non-included angle. This is the side, side, angle case. We can't spell it the other way around. So don't be like all angle, side, side case. Y'all are old enough and mature enough to have the ASS case, but no. Sometimes we teach this to high school students, and you do that backwards once, and they're done for the rest of the semester. So the side side angle case causes problems. Side side angle is the ambiguous case. Side side angle is called the ambiguous case. If you have two sides and the angle opposite one of those sides, you have an opposing pair. So you definitely want to use the law of sines, but we're in what's called the ambiguous case of the law of sines. The reason this is called ambiguous is that we could end up with 0 triangles, 1 triangle, 2 triangles, or 1 triangle. That's the ambiguous part. It could be 0, 1, 2, or 1 triangle. The reason that we could end up with two triangles, the reason that this is ambiguous and that this could happen, the reason that we might end up with two triangles is that quadrant 2 angles still fit in a triangle. So the reason that this ambiguous case happens is that quadrant 2 angles will fit in a triangle. Side-to-side angle is the ambiguous case of the law of sines. Because we could have 0, 1, 2, or 1 triangles. We could have two triangles because quadrant 2 angles fit into a triangle. It's possible to have a 120-degree angle in a triangle because the sum of the angles needs to be 180 degrees. If I use 120 degrees in one angle, I still got 60 degrees left to put on the other two sides, or to the other two angles. That's why we might have two triangles. Any questions? We're not going to do an example of the ambiguous case. I just want you to know that side-side angle. You have two sides, the angle opposite one of those sides. This is the ambiguous case. There could be 0, 1, 2, or 1 triangles. Two triangles could happen because quadrant 2 angles fit in triangles. Any questions? Comments? Going all super still. You don't have to memorize the law of sines, you just have to remember the law of sines. The ratio of the sine of an angle to the side opposite that angle is constant in any triangle. A over sine A alpha equals B over sine beta equals C over sine gamma. See, I can't even say that this one. I can only say it this way. Sine alpha over A equals sine beta over B equals sine gamma over C. All right, that's going to do it for today. I will see you all on Thursday. Everybody have a good couple of days. And thanks for playing.